Welcome, everybody. We have been running quite a number of webinars during this year. So for the ones who have been listening to me before, don't worry, we'll have also new things to tell you. So we'll talk more about customer use cases. We'll share some validation examples. And this is the main topic of today. We'll share more details regarding simulators. What we will not talk about is NVH, so noise, vibration, harshness. We will leave this to another time. And let's start with this quote, which I found earlier this year, where the CEO from BMW was presenting at a conference. I think it was, naturally, near Munich. And where he was saying, okay, it's not about who's having the largest screen in the vehicle, but winning will be the company who offers the best emotional experience for drivers. So the driving experience is the core of the development at BMW, and I'm certainly, it is not only BMW, it's every automotive company in the world. They want to present the driving experience which represents best their DNA. But how is a driving experience defined? And we like to put it in three buckets, if you wish. The first group, it's about the interaction of the driver with the vehicle. So how does the vehicle respond to the driver inputs? So that's classically described in terms of the ride and handling properties and the noise, vibration, and harshness properties. The second area is becoming more and more important. It's the interaction between the driver and all the electronic assistants we have today in the car. So how is this interaction, and how does the driver feel? Are the assistants helping them, or are they sometimes disturbing them in what they want to do with the car? And thirdly, also gaining a lot more important, we'll talk about this in the presentation, is the interaction between driver and controls. So do you easily find the things you're looking for example, how to turn on the heat in your car, how to answer a phone call and these kind of things? Is it intuitive, and is it not distracting you from your task driving a vehicle? If we look at all these things, driving experience, there's one thing we need to, in order to assess whether we are reaching our development goal, and that's the car. So during the development phase, we need to have a prototype, and as we all know, the limitations of prototypes, they're very expensive, and they're available within the development process pretty late. So with the problem that we have feedback maybe too late in the development process. And if we look at all the challenges we have to address today, new architectures like electric vehicles, we have increased complexity. We're being asked to develop in a more agile way. And then we have the two things which will never go away. We're being asked to do this in less time and at less cost. And if we wanted to address all these challenges, we're facing that hardware prototypes and the related testing, that's the bottleneck. So that whatever kind of initiatives we do with digital initiatives and so on, as long as we depend on hardware prototypes, we are facing an issue. This doesn't have to be like this. And let me share one example from Ford Motor Company.
Let's see if we can give you a little bit more sunshine in there.
Yeah, it's a little cloudy out. Brighten my day, Randy.
We're in the room with a dynamic driving simulator, and this is the machine that actually translates the models into motion for the human to experience. I've always been interested in cars, just since I was a little kid. Anything I could drive, right? Things that gave me that excitement or needs for speed. But I also wanted to see why it was fast or what could make it faster. So the natural marriage of those two is to develop vehicles.
All right, we got that all loaded up for you and you're good to go.
It's actually pretty outstanding how many different suspensions and tracks we can go through in a single day here in the simulator versus what we used to do physically. We have some days where we do 50, 60, 70 runs of different suspension parts and tracks, and you would never even get close to that kind of number when you're doing it in the physical worlds.
All right, I've been told it's time to take a rainy day at Lommel here.
All right. Transport me to Europe, please.
We've brought the globe into one virtual environment, whether that's working with our European team or the US team.
You can try things where you normally would have to build prototypes, so you can make changes within a few mouse clicks.
We have a camera installed in this simulator room that we can stream over our system, and the people that are in a different country or a different region can see the simulator running.
The quality of the vehicle is going to be better just because of the sheer amount of work that we can do in a quick manner. I'm trying to give the customer the vehicle that I want. I want to be confident in the truck as it's towing a trailer down the road.
We can take a trailer that's loaded up to its maximum weight, and we can drive that in the simulator and see how the vehicle reacts to it. We can also take that trailer and load it in correctly, like a customer might do in the field, and look and see how the vehicle responds to that.
Uh-oh. See? Went off the track. I tried to do a little too much. At least I didn't hit the guardrail.
So the first time I got in the simulator, it was a surreal experience to be able to drive the models that I've been developing for months on the computer and truly interact with them. Some of the features we've evaluated and developed on this simulator: adaptive cruise control, lane centering, all the way up to Blue Cruise and Active Glide. We're able to safely put drivers of various levels of capability in very dangerous situations, cut-in situations on the highway, let's say. And if something were to go wrong, we just reset the simulator. Our virtual engineering efforts allow us to do more work up front, to work out potential issues with our systems well ahead of prototype vehicles.
Making decisions on programs earlier on and getting the target right for the customer is going to help us in quality, because you're not going to have the late changes. We have real-time data streaming on everything we're doing. From when we opened in February to now, I think we've easily exceeded even my own vision. Instead of people talking about it as a piece of technology, they're using it as part of the mainstream development of programs now. When you've gotten to that point with a piece of technology where it's ingrained and expected, that's a huge win.
So I think what Ford has implemented here is a human-centric development approach, where they now have the ability to assess the driving behavior throughout the development process, and they're not depending on hardware prototype testing. So these are just some other examples where people are assessing the driving experience based on virtual models in combination with driving simulators. Whether it's the gentleman up here who is looking at noise, vibration, harshness, this one looking at virtual reality applications, or this gentleman whom we will see later again racing a virtual car on the Nürburgring test track. In order to come to a realistic driving experience, we have to do three things. We have to provide a realistic vehicle model so that you have realistic motions and accelerations, so that your feeling are realistic. We need to provide a realistic graphic environment, so what you see is realistic, including weather effects, these kind of things. And thirdly, your noise and sound need to be realistic. And all of these three components need to be synchronized, and this then gives you a full immersive experience of the driving or of your computer model of your development. And then you can make design decisions and optimize your design. You may say, okay, driving simulators have been around for quite some time. So what's new? And what we feel what's new is that we are seeing that the industry is reaching a tipping point. So where things becoming easier going forward. And what is helping us to reach this tipping point are the developments or enhancement we have seen in these 4 areas. So we have been doing a lot more CAE simulation, and as a result of this, our CAE models are a lot more mature, a lot more accurate. Nowadays, we have a lot more powerful real-time computing environment. And mainly thanks to the gaming industry, virtual reality, extended reality, graphic rendering has improved greatly. And these 4 things coming together and now enable us that simulators can become part of the mainstream automotive development. And here just 4 examples of companies of, let them call it early adopters, who are using driving simulators to enhance their development, whether it's Bridgestone in combination with Lamborghini, who jointly are doing suspension and tire optimization, Ford working on lane keeping assist, GM improving the NVH behavior of cars, or IDIADA, who together with Mahindra focusing on world-class dynamic performance. If you're interested in these applications, you just go to our YouTube channel and you can listen to the individual presentations from these companies at our last year's Zero Prototype Summit. Let me just dive a little bit deeper on IDIADA and Mahindra. This was the first time IDIADA and Mahindra used a driving simulator in a vehicle development program. Basically, the target of this program was to come up with a car which has a top vehicle dynamics performance. And they looked at the metrics or the things they could achieve with the driving simulator. They were saying, okay, if we just use offline CAE, then we can reach 60% of the maturity level of our design. So basically 40% are still left in the old way for physical testing. When they're now using the driving simulator, they could improve the maturity by additional 25%. So the amount of testing, remember before it was 40%, now remains at 15%. So if we draw the line a little bit different, so what's the potential of reducing prototypes over time? We see, okay, there is the enabler, it's the offline simulation. The offline simulation can reduce prototypes, but the offline simulation can only address the objective part of the design process. But all the subjective assessment, okay, requires hardware prototypes or driving simulators. And we feel if you combine these 2 things, efficient offline simulation environment and driving simulator, then you can have the full potential of reducing the dependency of hardware prototypes. You may ask, okay, what are the critical success factors in order to implement driving simulators in your development process? And we like to describe it in 3 words or 3 terms: the right simulators, the right models at the right time. Right simulators will dive into more detail, but in a summary, okay, you need to have scalable simulators, you need to have simulators which allow you multi-attribute assessment, and you need to have simulators which can give you the performance range you need. whether these are large displacements or high frequency excitations, you want, for certain tasks, you need all of this. And we'll come back to this. Right models, we all know this, early in the design phase, when you do concept analysis, okay, you're looking at a very large potential design space. So you have little data available and you want to look at a lot of variance. So the model usually is a vehicle model with conceptual suspension. You haven't decided yet which suspension to use. And then while you move on, you focus on a specific design, you will have more data available, and then it's also required that you can refine your model, that you include more data from your refined design, and initially you include control systems via software. And when the control department matures and can deliver an electronic control unit to you, you also may want to plug this in via hardware in the loop simulation, so that the digital twin of your design gets mature and refined while you're moving on through the development process. All of this can only provide value to you if this is available in time. So it doesn't help you the most refined model if it comes 2 months after you had to make a decision. So it's important that you implement a digital development plan where, based on validated templates, based on available data, you generate models for the user community. User community can be, for example, a suspension designer or a controls designer. User community are the ones who want to evaluate the driving experience on driving simulators, or user community are the ones who want to do continuous testing of the latest control algorithms. But let's talk more about driving simulators. This is our lineup of driving simulators. So starting with a desktop simulator, where it just has interactive control elements. You have a steering wheel, you have pedals. And then when we're moving on to compact, static, and to dynamic, we're adding more detail and adding more feedback, so to enhance the driving experience. And we'll talk more in detail about these different simulators. But before we do this, let's look at this, what they have in common. They have in common that they all are using the same compute backbone, and that's our real-time system powered by concurrent real-time with the name AutoHawk. So what AutoHawk is, it is real-time hardware. It comes with a real-time operating system, a real-time software, and the I/O cards you need. What's important for you to know is AutoHawk is an extremely powerful platform, so it also can grow with you. I think what we are seeing, the trend is that the simulation models become more and more complex, and you don't have to worry that they won't run in real time. So AutoHawk is a very powerful environment. It is proven in the industry. It's based on Linux, and it's open. I think that's also important to know, that whatever you want to do, okay, you can implement this via I/O cards or software in the system. Okay, but let's now have a look at these different simulators and what we feel what you can do with it. Okay, the desktop simulator, that's our entry level. So what you can do here, okay, you can interactively drive a vehicle. And basically, with this, you can test whether the vehicle performs as it's supposed to perform. The feedback you're getting is, okay, you see how the vehicle moves, for example, here over a racetrack. And you can record signals and see whether the basic function is okay. So if we look a little bit more detailed what's comprised here, okay, we have a steering wheel, more or less similar to what you're used maybe in gaming world. You have pedals, like we said, the auto desktop, and we recommend you have curved monitor so that the experience is quite okay. You can also use this to test your control algorithms. It's more or less, it is a platform where you interactively first see, does your vehicle model work, and then does your vehicle perform as expected? Is the basic performance there? What you can't get with such a system is, okay, evaluate the steering feel, because you're not getting these feedback. Or you don't get the feedback, okay, how about if I brake, what's the feeling on my brake pedal? You're getting more feedback from what we call, that's our compact simulator. So it's basically where you can do vehicle dynamics in the, we feel, most compact form. So where here you can look at the steering feedback, you can look also at the brake feedback. And then there are some other things we'll discuss in the next slide, what we call active seat and belts. So that's the setup, where you have the driver's seat, you have a cylindrical screen, projector, and again, the auto hold. But then you have some options. Okay, it's like buying a car. So you now can tick and say, okay, I want to have the steering assembly. I think everybody who has a compact simulator has a steering assembly in order to get accurate forced feedback while you're driving the virtual vehicle. Active seats and belts might be something you also wanted to have. Okay, it's a compact, so this simulator does not move. But maybe you want to get a little bit feedback when you accelerate or when you brake. And this is what these active seats and belt do. So basically, when you brake, the tension of your seatbelts is increased. If you have lateral acceleration in the virtual vehicle, then we have some air cushions which blow up, so that you also get the feedback there of the acceleration. Active brake gives you brake feedback. And then there are other things you might want to also use depending on kind of application you have. Biotelemetry and eye tracker. Okay, it's basically maybe you're working on some ADAS application and things like this, where you want to track how people are focused on the driving and what other things they're doing. Shakers and speakers. Shakers gives you a little bit more feedback on the road roughness. And then when you're working on ADAS and autonomous vehicles, okay, you want to have the extra of cameras, radar, and sensor fusions. So the compact simulator, we feel, is a very good place when you work on autonomous vehicles, control systems, and when you want to prepare vehicle models for further dynamic studies. And we'll show you some examples where people using either the compact simulator or the next one, the static one. From a movement standpoint, so the kind of feedback you're getting, it's the same thing like the compact, but here it's built from a real car. So it starts with you not only have the driver, you can also have a passenger there. And by having a real car, it gives you more immersive feedback on HMI issues and these kind of things. The extras you can have are the same thing like in the compact simulator. And applications here again, controls development, HMI development, and we'll show you examples. So far, we had the opportunity to get some steering feedback, some braking or acceleration feedback on the pedals, but things weren't moving. And with the driving simulator, here in this case, 9 degrees of freedom, driving simulators, okay, we're now talking about real vehicle dynamics, and you're getting now having the ability to have accelerations in all degrees of freedom, and this now gives you a lot more realistic feedback of the driving experience. And let me show you a video.
DiM, the family of turnkey yet open driver-in-the-loop simulators from VI-grade, provides automotive engineers with a complete set of innovative, integrated driving simulators for a new generation approach to system-level simulation. The dynamic configuration provides motion feedback to the driver thanks to an innovative 9 degrees of freedom moving platform with reduced dimensions and larger displacements. At the bottom of the installation, you can see the base frame that comes in 2 pieces on which air pads are sliding smoothly. The design of the lower stage features 3 air pad boxes housed inside the lower part of the motion platform called the tripod. The 3 linear actuators connected to the tripod allow 3 degrees of freedom, longitudinal planar motion, surge, lateral planar motion, sway, yaw. These 3 degrees of freedom give the lower stage subsystem the ability to exploit at best all the available workspace. On top of the tripod, we find the hexapod that delivers the additional 6 degrees of freedom and is characterized by top-class heave displacement and high-frequency motions in all directions. Let's have a closer look at the motions in all 6 directions. All VI-grade dynamic driving simulators are equipped with a realistic cockpit obtained from a real car. This increases dramatically the realism of the driver experience. Standard components are touchscreen, shifter, steering system and dashboard, active brake and pedals, active seat and belts, mirrors, eye tracking camera, speakers, car body with carbon fiber components, vibration shakers. All this can be easily mounted on top of the hexapod thanks to a plug-and-play interface. Total immersion is guaranteed by a top-class visualization system using high-frequency projectors and a wide conical screen. For our DiM driving simulators, we went beyond the basic 6 actuators design to provide a larger workspace while maintaining high stiffness. This allows the system to be more relevant for low as well as for high frequencies, which characterize automotive chassis design. With the DiM driving simulators, you will have the ability of studying both vehicle dynamics and ride on the same motion platform.
Okay, the system you have seen there with these linear actuators, the workspace is limited up to 3 meters. If you want to have larger workspace, then we recommend to you that you use the cable simulators, which are here. So basically, the linear actuators are now replaced by cables, and this allows us even greater movements. The rest of the configuration is the same. You can have these same add-ons, and you can have 4 meters workspace and even larger, 6 meters, 7 meters, depending on what your requirements are. All of this is available in an open environment so that you can pick and choose the components which fits best to your company's ecosystem. So you can use our car models from VI-grade, or you can use car models from IPG, from Modelon, from the Modelica community, Daimler, or Hexagon. And then goes on with tire models, Cosin, Fraunhofer, Megaride, or Siemens. And the same is true for other components. So important, we certify third-party solutions that they run on our system, and so that you can adopt our driving simulators into your ecosystem. So as a summary, we have desktop, compact, static, and dynamic. And with the applications, basic validation of your design. With the compact, you can do a lot more with respect to ADAS with the compact and the status, with respect to ADAS and controls. And dynamic gives you the most complete feedback regarding the driving experience. Let's talk about references. Let's talk about accuracy, models, and return on investment. And I want to talk in more detail about these 4 use cases, one from Hoffmann and one from Ford. In both cases, these companies have been using the static simulator. And then we'll talk about the dynamic simulator, 2 use cases, one from Goodyear and one from Mercedes. For all of this, there's more detail available. So it's these 3 things have been presented at our summits in Europe and North America. You just go to our website, Google this, or go to Yahoo channel, and you can find it. The Mercedes, this was published by Mercedes. You just go to YouTube and search for the AMG Project 1. But let's talk first with Hoffmann. So they presented last year in the US. So Hoffmann, they do develop solutions in the context of HMI. So very intelligent head-up displays and things like this. And for them also the question is, okay, how do I develop and test my design? Of course, then you could put it in the car and drive the car around the world, but that's not the most efficient way. So what they did is they interfaced their system with our graphics environment, which is called VI World Sim. So VI World Sim gives you a realistic rendering of your environment. It has traffic models in this, and with this, you might imagine, so if you hook this up to your HMI application you're developing, then by just using a static simulator, you can test your development and also use it as a demonstration environment to potential clients to show them what your system is capable about. You can test this at your facility. You don't have to drive around the world. So we are seeing this application more and more, so that you also here you have in the very early phase of the development the ability to check whether the design for your HMI is satisfying your requirements, and you can check with customers. You can do customer clinics and see how they like your new development. Fourth, lane keeping assistant. This is a controls application, and one of the challenges when you do such a controls application, it is assembling the model. So if you want to test the lane keeping assist system, okay, you need to have a basic vehicle model. You want to have the ability to model lots of different roads, not only the simple bending here, which you see. You need to have the ability to include a rear camera in your system. You need to include the electric power steering, which comes as a software, as a digital model from a supplier, and you need to include your control logic. So Ford has been using VI-grade real-time as the integration platform for these different modules. And then they use the static simulator. They said for testing the function of this lane keeping assist, they felt it's sufficient that you use a static simulator. For them, it was the most important is the steering feedback. And with this, they felt quite pleased with the static simulator they have at this facility. Important for them was that they implemented the same calibration layout in the simulator like the test drivers are used in the prototypes. So let's say that the learning curve for the test drivers in the simulator was pretty steep. Okay, so we now looked at two applications of a static simulator, and now let's move to dynamic simulator. And I got this question of multiple times, okay, how accurate is your simulator compared to reality? This is a video which was, actually these are two videos. This was taken at the Virginia racetrack on the rear track, you see on the top here. And this is now the simulator running a virtual model on the same test track with I'm not sure whether it was the same driver, but also with a real driver. And this hopefully already gives you a feeling or the impression, okay, it looks similar. So I think the driving simulator, at least from the overall impression, is able to replicate what you'd see in reality. But of course, you know, visuals are not sufficient, so you need to do a little bit more work. And that's what Goodyear did. This was presented last year in Italy at our summit. They built a computer model for the Golf. Basically, they had brought it to IDIADA. IDIADA measured it for them, and then they basically came up with a real-time model with all the characteristics you need to have, your characteristic curves, your mass, moments of inertia, and so on. Tires, they want to also demonstrate how well their digital path works for tire. So basically, they have a proven finite element technology, and they use this in order to generate data for a tire model. And then they also validated that this tire model was representing well the actual data of a tire. And then they assembled everything and put it on the simulator. And there the task was, you have how much? 6 different sets of tires. And then they had specific events they drove on the simulator. And then they asked their drivers, on the simulator to evaluate the tires and do some ranking for the steering feeling and the high-speed handling. So far, the virtual part, and then they did the whole thing in reality on the test track. And again, drivers were asked to assess the different tires. And what you can see here, what is it? Blue is simulator, yellow is reality, and you see, except two or three cases, I think the ranking was the same. And this is what you want to know, or you want to be sure that if you're evaluating design alternatives, that you're making the right choices, and that the choices you make are the same ones you would do in reality. And I think, at least for me, this shows good results and demonstrates the accuracy you can achieve with driving simulators. And with this, they are now able to change their development process. So where their initial development process was, okay, they do some upfront analysis, they do lots of FEA, but then it used to be based on their final element results, they were building prototypes, shipping these prototypes to the OEMs, they did testing, okay, and then you do the iteration and the loop. What they now can do, also using artificial intelligence, machine learning, they have a lot more data available. They do the final element analysis to produce and optimize design alternatives, but then they evaluate these design alternatives on the simulator so that they have a far higher confidence when they build tires that these are the tires their customers want. And with this, they cut time and cost. And that's also a quote from the executive vice president in Goodyear, who was saying, okay, he's expecting he will get his return on investment. So that, of course, there's an investment needed for these simulators, but he is confident that they will get this back by the time and money they're saving in the process. For AMG, what this story is about, this is the car Project One. So this was a project AMG undertook for their 50-year, I think it was 50-year anniversary. It's basically a street car with a Formula One engine, plus supported by some extra electric motors. So if you wish, a really high-powered hybrid car. In order to get really realistic feedback driving this car, they had as a hardware component the brake system, so that they get realistic braking feedback. And they brought professional drivers in order to optimize the car. And if you look at the video and listen to what the feedback from the driver, that's to me also is a confirmation. If professional drivers being on a simulator are excited about the capabilities of a simulator, this means you're providing value with the simulator, and the simulator provides realistic driving experience.
During a test, we got the measurement data where we can have a look at G's and how the car responds to the driver. The specialty about the Project One cell we see here is we got like torque force feedback, torque machine, the full braking system from pedal to brake pads. Today we got Maro Engel coming round. He won the 24 hours race at the Nürburgring in 2016, so he knows his way exactly around the Nürburgring. With a race driver, you got really reproductive driving, so you can constantly go into the same direction and same spots and analyze changes pretty exactly. They're used to drive these kind of performances, so they give you direct feedback and precise feedback.
Die Beschleunigung ist natürlich schon mega.
Sitting in the car feels amazing. I mean, it's such an amazing project, and when you pull away in the simulator, you feel straight away, you know, the huge power, very high precision. The car is really all about performance, and you can feel that, and it puts a smile on your face.
With this, it's a little bit, just a summary. So what we feel, if you implement a simulator-driven development approach, you can reach higher innovation. The AMG folks set a new record on the Nürburgring with this Project One. You can be faster. Volvo reported that they cut development time by half, and you can save prototypes dramatically. If you want to join the road to zero prototypes, we offer you that we work together, determine where you are today. So what are your capabilities with respect to modeling? With respect to the resources you have? We would define where you want to be and would work together how you would get there. Basically, based on the target, what you want to achieve, we would design your zero prototype lab, where basically you would define, okay, these are the kind of simulators you would need in order to achieve your development goals. Since we're dealing with hardware and also simulators need space, you need to provide these space, so this will take time. So what we can do in the meantime, while you're waiting that your simulator will be delivered, that your simulator room will be ready, we offer you an acceleration program where once everything is ready, you're also ready. So basically you're invited to come to our sim centers around the world, and where we would take the jobs from your development and you would be learning on the job. We would enhance your vehicle models, your graphical assets. You would train your test drivers and operators and streamline your digital development plan. So once the simulators are delivered to you, you and your processes are ready for these simulators. With this, I would like to finish my presentation. I would like to invite you to come to our 23 Zero Prototype Summit. The first one we're having in Italy, northern Italy, close to Venice. And you know, I can talk for hours about on PowerPoints, but this summit provides you the unique opportunity. You can write various simulators yourself, and you can listen to customers or to people from the industry who are using the simulator and sharing their experience. So, as I said, there's one in Udine, and there will be other ones in Asia and in the US later this year. I would, if you're interested, go to our website and get the dates. With this, thanks for listening, and I'm looking for your questions.